Um, Video part 1 of the questions. So number 1, the traverse pulse video. 1A, describe how the vibration of the slinky compared to the direction of propagation of the pulse. So the slinky was stretched out in a horizontal direction across the classroom, and a pulse was introduced into the slinky by vibrating the first coil left and right. Energy moved through the slinky, and the energy was transported from left to right, causing the individual coils of the medium to vibrate up and down. Part B, or 1B, describe how the size of the pulse changed as it traveled back and forth in the slinky. Give a reason for the change. So as the pulse traveled down the slinky, it started off big and came back. It was smaller. This is because energy is lost as it makes its way down the slinky and when it comes back. 2. Longitudinal pulse video. 2A. Describe how the vibration of the slinky compared to the direction of propagation of pulse. The slinky was stretched out across the floor, and a pulse was introduced into the slinky by vibrating the slinky up and down. This up and down motion caused the slinky to vibrate, and it traveled through the slinky from one side to the other. What was the difference between the observed transverse pulse and longitudinal pulse as it relates to vibration of the slinky? The vibration in the slinky was different for each wave. For the transverse wave, the vibration moved left and right, and for the longitudinal wave, the vibration moved up and down. When the vibration traveled back the other direction, it came back bigger for the transverse wave than for the longitudinal wave. 3. Different amplitude videos. Describe what the initial amplitude or size of the pulse depended on. The initial amplitude of the pulse depends on the amount of energy it transports and the amount of energy that is put into the moving of the slinky. Did the change in the amplitude of the pulse affect how fast the pulse traveled back and forth in the slinky? Changing the amplitude of the pulse did affect how fast the pulse traveled back and forth. The larger we made the amplitude, the faster it came back, and this is because the greater amplitude means the more energy, and the more energy it has, the faster the pulse will travel. 4. Frequency videos. Did the change in frequency affect how fast the pulse traveled back and forth in the slinky? Briefly explain. The more frequent we move the slinky, the pulse did not travel back and forth faster. This is because frequency is not speed, and the number of pulses per second changes, but not the speed. And then B, describe how the wavelengths changed as the frequency of the wave changed. So as the frequency increased, the waves got shorter, and this is because the slinky was moving faster and more often back and forth, causing the wavelengths to be shorter and occur more often.